Assalamu alaikum everyone. I am Mohammad Shahan Sarkar, MSc student in Tripoli at BUET. Today I will present my project on temporal forecasting of relative humidity and air temperature in the Rangpur Division using multivariant RMA and multivariant RNN model. This work was supervised by Dr. Mohammad Ariful Haq. I will focus on why these variables matter, how I built the model, and which one perform best for our region. Here's the outline of my presentation. I will start with the motivation and background, then I briefly literature review, following by aims and objectives, then the study area select and data collect, the methodology and modeling, and finally the result and conclusion are recommendation. Relative humidity and temperature are core division in climate and weather system. Accurate RAs forecast support agriculture, industry, public health, and disease transformation modeling. Rising goal temperature and global variability increase the urgency of relative prediction. Study can also co-integration between RAs and temperature, so modeling them together can capture meaningful interdependence that improve forecast skill. There are many forecasting approaches like statistical, stochastic, probabilistic, and AI-based model. In this study, I compare two multivariant approach with different modeling philosophies. Multivariant RMA, which is statistical and linear, versus multivariant RNN, which is data-driven and nonlinear system. My goal is to produce actual robust forecast for our region by leveraging multiple climate covariant, not just the target series. Key point of this literature study is first, data quality and pre-processing matter a lot. Second, feature selection improve generalization, and third, model comparison should use multiple metrics, not just one, to capture different except for forecast quality like correlation, error, magnitude, agreement. Those points shape my study design. My objectives are to collect and reprocess the methodological data, build and compare a multiple RMA and multiple RNN for RAs and air temperature, identify the actual model, and forecast RAs and temperature trends up to 2030 for Rangpur Division. The Rangpur Division was chosen due to its agricultural importance and sensitivity to climate variability. Forecast improved here can directly depend planning around farming, irrigation, and heat humidity related health risks. I compare 45 years of data, 1981 to 2025, covering relative humidity, air temperature, wind speed, precipitation, Plummer Drought Sensitivity Index, which is called PDSI. The long-term record supports training, validation, and testing across different climate regime and exempt improving model robustness. The RA's prediction, I use temperature. For RA's prediction, I use temperature T, precipitation P, wind speed, and PDSI as covariant term. For temperature prediction, I use RAs, P, wind speed, PDSI. These multivariant farming like model capture cross-variant signal like drought, soil moisture strength, and precipitation process that influence both RAs and temperature. For RNN, sliding windows fit sequential pattern. For ARIMA, I select order based on designations, checked, and information criteria. In this methodology, I select study area, then data collect, then decision is this data is stationary or not. If it is not, just differentiating between data, or if the stationary data is yes, then the model will work, and then compare method using some parameters, which is evaluate which model is good. Finding best model, then future forecasting. I evaluate with correlation coefficient R, exploration variance R square, index of agreement D, root means square error RMSE, and means absolute error MAE. All parameters help avoid over relating on a single score and given a balanced view across model. For multivariant ARIMA, here three terms: one auto regression, second integrate, and third moving average, which is calculate this model is work. The model is transparent and perform well for linear dependence. Actually, it is our baseline model. In RNN model, have different sections. Here, firstly, loaded data set in Excel format. Then this data is clear and handle missing data. Then scale feature. Then reform the time series into supervised sequence. Then split into train and test. Then build model. Train and validate the model, and then evaluating using multiple metrics, and then forecasting future R, age, and temperature, and finally plot all the outcome. RNN model learned temporal pattern and interdependence directly from data. The architecture has three parts: input, hidden layer, and output layer. By using power of multivariate RNN, the LSTM unit helps capture longer range dependence and nonlinear integration among RAs, temperature, and climate covariant. To balance speed and accuracy, I tried with base size of 32 and epoch size is 75. This setting consistency gave stable covariance and strong validation performance in this dataset. Here is RAs forecasting with multivariate ARIMA across training and testing data. I highlights where ARIMA track seasonal component well and where is lag during nonlinear intention or repair sense. Useful to understood strength and limitation of the linear model of the dataset. Now the RNN result of relative humidity. Notice how the RNN adapts to nonlinear shift and multivariant interaction. In generally follow peak and trough more responsibility and maintains low error on the test period. This is reflects in the matrix. Next slide. Comparing matrix, the multivariate RNN achieve higher R and R square and D, and lower RMSE, MAE than ARIMA for RS. In pain test, better correlation, better variance capture, better agreement, and smaller error indicates stronger prediction performance in the region. For temperature, ARIMA again capture to broad structure but can unfit complex dynamics or covariant like RAs, PDSI, and wind speed. The RN temperature forecast show stronger alignment to observe series, especially around transition period. The model appear to utilize across variable information like RAs, temperature dependency more effectively to reduce error. Matrix for temperature again favor multivariate RNN higher correlation, agreement, and lower RMSE, MAE for the application in Rangpur region. After comparing the two models, here is some conclusion and result. The multivariate RNN outperform multivariate ARIMA for both relative humidity and air temperature in the study. Why? Because RNN capture nonlinear cross-variant dependence better, producing higher accuracy and agreement in both training and testing phase. I recommend some points. Firstly, adapt multivariate RNN operationally for relative humidity and temperature forecasting in Rangpur region. Predictically retrain with new data to maintain accuracy. Consider adding more physical covariant like soil moisture and testing sequence length, tuning and regression. And finally, for deep math, wrap with confidence interval and model monitoring. I will list the primary reference here. Thank you for your valuable time. I am happy to take question on data preprocessing, model configuration, and operating diplomats in forecasting workflow.